Hey guys, this is Alan with Bothell STEM Coach, and today we're continuing on with AP Physics 1, and we're looking at more circular motion problems. As usual, I suggest that you pause the video right now, take a look at the problem, try to do the problem. Once you've gotten as far as you can or you've completed it, come back and watch it and see if my methodology aligns with yours. We get the same answer. Okay. So a ball of mass m attached to a string L moves in a circular and a vertical plane as shown above. At the top of the circular path, the tension on the string is twice the weight of the ball. At the bottom of the ball just clears the ground and air resistance is negligible. Express all answers in terms of m, L, and g. Determine the magnitude and the direction of the net force when it's at the top. Okay. So at the top here, we have mg going down, and I also have force of tension from the rope going down. The rope can't push, it can only pull. And from up here, basically I have gravity and Ft. Now we're told that Ft is equal to twice, the tension in the string is twice the weight of these 2 mg. So the net force up here is equal to mg plus Ft. That's equal to mg plus 2 mg, and that's equal to 3 mg, and it's downward. Okay, so that's the net force. Does that make sense? Because the only thing acting on here is the rope downward, tension downward, and gravity. There's nothing else pushing on it. Determine the v naught of the ball at the top. Well, we know that this F net has to equal centripetal acceleration, ma, which is equal to mv squared over r. In this case, r is L, and this is v naught. So v naught squared over L. Okay. And that has to equal 3 mg. The m's cancel, and I solve for v naught. So v naught squared is equal to 3 lg. And so v naught is equal to square root of 3 lg. Okay. The string is then cut when the ball is at the top. So now it's going to determine the time it takes for the ball to reach the ground. Okay, now its initial velocity is this v naught, and it's going horizontal at this point, because that's at the very top, its v naught is there, and then it's going to fall to the ground like in this path. Okay. Now, this is a little bit of kinematics, right? It has no vertical initial velocity, so whenever you're doing time to reach the ground, you're always looking at distance and in the vertical direction. So we use the kinematic equation delta x equals v naught t plus 1/2 at squared. Okay, but in the y direction, we're gonna say down is positive, just to get this right. What's the distance that it's gonna travel in the y direction? Well, it's gonna go from here to the ground in the y direction. So it's gonna travel L to L. V naught t has 0 initial velocity in the vertical direction, in the y direction, plus 1/2. A is pointing downward at 9.8, so it's g, so it's positive g, 9.8 meter, or we'll just say g, t squared. Positive is down. Yes. Yeah. So 2L is equal to that. I'm going to multiply 2, so I get 4L over G is equal to T squared. So T would be equal to the square root of 4L over G, which is equal to 2 root L over G. Okay, so that's the time it takes to reach the ground. D, determine the horizontal distance the ball will travel before hitting the ground. Well, it's the time in the air times its horizontal velocity. That's the distance it's going to travel. So it's delta x is equal to v naught t, and because there's no acceleration in the x direction, because once I've cut it, the ball is just in just sort of projectile motion. So v naught in the x direction was square root of 3 lg. The time it's in the air is this 2 root L over G. That makes this 2 root 3. Wait, I got a root L times a root L. That's 2L root. Oh, and the square root of G's cancel. So 2 root L root 3. Yeah, I think that's right. Okay, it's a pretty quick one. Hope you guys found that helpful, and I'll see you guys in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content, and see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.